So we're given a scenario here where we are removing all of carbon's electrons, all 6 of them. And we're going to graph it and then kind of predict where the biggest jumps are going to be. So carbon is number 6 on the periodic table. It means in a neutral carbon atom is going to have 6 electrons. And so the first electron is going to go into or first 2 electrons are going to go into the 1s orbital. And then the next 2 electrons are going to go into the 2s orbital, and then the remaining are going to go into the 2p orbitals, and something like that. Got energy going up like that. All right, so and we can kind of correspond this to, let's do like this. Carbon, there's your 2 electrons right there from the 1s orbital, and then 1, 2, 3, 4. All right, those are your 4 valence electrons in the n equals 2, the second energy level. All right, so either way you look at this, this may be easier to look here on this simpler drawing. But the first electron is we can remove that, and that's going to require the least amount of energy, right? Because it has, the first one's always the easiest. Okay, so that's going to be the lowest number. And then the second one now is going to be a little more tightly bound, because after the first one is gone, there's 5 electrons, right? After this guy's gone, that guy's gone, there's 5 electrons, but there's still 6 protons. So the nuclear charge is now each remaining electron has a bigger piece of that nuclear charge. So it's going to get not exponentially, but it's going to get more. It's going to require more energy to remove each successive electron. So that's going to require more. This is the ionization energy for the first electron. This is going to be ionization energy for the second electron, and then this one's going to require a little more, probably a lot more, because each successive one, there's your ionization number 3 and ionization energy number 4. All right, by the time you get here, we're thinking like double, triple what it took for the first one to remove, because this one, by that time that one's there, it's got 6 protons, and it's like every electron gets to have like 2 protons each. You can think of it like that. All right, so here's going to be the big jump. Now, once that energy level is gone, okay, so once all of these are gone, now you get to the core electrons, and those babies do not want to go home. These 2 core electrons in the 1s orbitals, they've got like front row view to those 6 protons, and good luck trying to get rid of those. That's going to be the big jump between the valence electrons, right? These guys, they'll leave. Just give them some energy, and these guys down here are the core electrons. They're going to require a very noticeable jump. So let's graph these and see if, let me copy these numbers over again. All right, get a little X and Y going on here. These are all going to be positive values. All right, we got kind of eyeball it here. There's I1, I2, I3, I4, ionization energy number 5, and there's going to be the last. All right, and we got the lowest one. We'll start here 0, and the highest number is going to be a little under 50,000. So we can do that. 50,000. I don't want to use K because K is already in there for kilojoules. Just write it out. All right, so that's 4, 3, 2, 1. Not bad. All right, 10,000, 20,000, 30,000 kilojoules, and 40,000 kilojoules. This is all kilojoules. All right, let's see what this looks like. First ionization energy right there is about a little over 1. So can barely see that. All right, and then the second one's going to be a little bit more than double. You can use like your graphing calculator, punch these numbers and get a. All right, so here's a little noticeable jump. That's a little less than halfway up for 3, and then 4 is going to be a little more than halfway up. Still barely budging, right? Like with the scale of my y, it's very difficult to see. Now here, these are our core electron. Oh, whoops. These are our valence electrons. All right. Now here are our core electrons. Look at that. You're going to have to really add some energy. That's close to 40,000 for the 5th electron, so maybe like there. And then almost 50,000 for that one. So there is the jump. These are our core electrons. It can be very difficult too. So there was our jump. All right. There's our core electrons right there.